All right, let's go ahead and look at number 11 from the test review. Find the required sample size needed to make a 99% confidence interval for the population proportion if the margin of error can be no more than 5%. This question actually comes directly from an example from your book, but it follows that we are now looking for different things than we have looked before. Because what we're looking for in this problem is we're looking for the sample size. In other words, we're trying to determine what is my value of n. And that is different from what we've done before. And actually, this refers back to a part of the notes that I kind of wanted to refer back to really quickly. So if you feel good about this part of the notes, you can go through this quickly, but I am going to go back to the notes for just a second. Because in the notes, we've had this page right here. How many people do you need? And you've got two different cases. In one case, P and Q are known or unknown. Now, in both of these situations, you use a simple arithmetic equation to calculate the sample size needed. And they're both simple manipulations of the margin of error calculation, but for the sake of the video for now, I'm just going to go ahead and give this to you. So the first function, or the first part of this function is going to be the z alpha over 2 quantity squared times p hat over times q hat all over the margin of error squared. Now, if you don't know p hat and q hat, you're going to use the exact same formula, but for instead of p hat and q hat, you're going to substitute something in. So the n is going to be equal to zeta alpha over 2 quantity squared times, we'll just do 0.5 times 0.5 because we're overestimating for the size of p hat and q hat, and we divide that by e squared. So that formula is going to allow us to calculate an estimation for all of our sample sizes that we need. Now, where that comes from, it's actually a really nice manipulation of the margin of error, and you might see that show up on the exam in some capacity, but not for a graded question. Hint, hint. Okay, so let's talk about example number 6. Here, I'm a newly hired manager that is a company with a cell phone service, and I want to determine how many people I need to poll to determine a valid estimate of the population of the United States that live in a household that have a cell phone but no landlines. That's essentially what that question's saying. And I want to be 90% confident with a statistic of 4 percentage points for the true parameter. So what I'm really doing here is I'm determining the sample size. I'm determining the sample size that I need. And I'm going to use the formula right above. And I'll go ahead and rewrite the formula right here just to make sure we all understand what I'm doing here. It's going to be z alpha over 2 quantity squared times p hat times q hat all over e squared. And hopefully you can see from this situation, I know that my margin of error is going to be 4 percentage points, so that's 0.04. In this case, I know nothing. You know nothing. So you're going to go ahead and assume that p hat equals q hat, and that all equals 0.5. The only other thing that I need is my zeta alpha over 2, and I'm going to get that from my handy-dandy chart. Referencing my chart, I can see that my critical value in this case is 1.64. So this problem really just becomes an arithmetic problem of just typing these values in. So it's going to be 1.64. I'm just going to do some simple substitution here. It's going to be 1.64 quantity squared times 0.5 times 0.5 all over 0.04 quantity squared. And this should give me a value of n. That's an ugly n there. This should give me a value of, oh, come on, n. There we go. When I type this into the calculator, I'm going to type it in numerator first, then the denominator. My numerator ends up being 0.6724. My denominator ends up being 0.0016. Then I'm going to type that into the calculator as a fraction, and I'm going to end up getting that 420.25. So the number of people that I need to poll to get an estimation is about 420. So really it's 400.25. You can't poll 0.25 people, so technically the correct answer would be 421. The next problem actually gets easier because now I can actually assume that I know something about the population. So now what I'm going to do is I'm going to be utilizing the same idea. I'm just going to have a value for P and Q. So in this case, my formula is n is equal to, same idea, I still start with my zeta alpha over 2 quantity squared multiplied by p hat times q hat all over my margin of error squared. The only thing that changes here is now that I'm going to have an estimation of the percentage of people that live in households that will have cell phones but no landline. So I know that my p hat has a value. So my p hat is going to be roughly 0.08. And I know that my q hat must be the complement of that at a 0.92. So then just substituting in everything else from the formula, I'm going to go ahead and have my zeta alpha over 2 value is the same. Now remember, where am I getting this zeta alpha over 2? This is all coming from that confidence interval. I know that my alpha value is referring to the parts of that normal curve that I don't care about over here on the sides, and that's all about my confidence interval. Because I've got a 90% confidence interval, my alpha is equal to 10, and my zeta value is where those values occur, where that happens. Remember, you've got this memorized. You have to have this memorized because those are values that are going to be come up very often, and we're not going to look into those individually as we go forward. So 1.64 is my zeta value. I've got my p hat, my q hat, and I know that my point estimate here is 0.04. Don't know why that changed colors on me, but it did. Go ahead and type in all these values into the equation. I'll go ahead and write it out one time right here. It's going to be 1.64 quantity squared times 0.02 times, 0.08 times 0.92, all divided by 0.04 quantity squared. Again, I'm going to do the numerator and the denominator separately. And for the numerator, I end up getting, I'm going to organize this a little bit, n equals, and my numerator, I end up getting 0.19795, denominator 0.0016. And when I divide that out, I'm going to get 123.7. Rounding that up because I can't have 0.7 people, it would be 124 people. So that's how you solve these types of problems. And I want you to notice something that's really cool. That number goes down drastically. We go home 420. It goes down drastically 123. Why did it go down so much? It's because I knew something about the population. That 8% that I've been given, that tells me quite a bit. And I'm not just guessing in the dark like I did here with that 0.5 and 0.5. So that helps me solve these types of problems. We've revisited the one from class. Now let's actually go back to the one that we had in terms of the test review and look at number 11. This is going to go much faster now, I promise you. So I know from earlier my formula to find n is going to be my zeta alpha over 2 quantity squared times my p hat times my q hat all over my margin of error squared. Remember that zeta alpha over 2 always comes from my confidence interval, and that's going to be, in this case, over 99% confidence interval. That tells me that my alpha is equal to 0.01, and that gives me my zeta value. In this case, my zeta value is going to be 2.58. Remember, you can get that from the table in your notes as well as from the calculator if you remember what zeta alpha is. All right, moving on. Let's go ahead and set up the problem. So assume we know that 0.40 is the sample population. That tells me quite a bit. That's telling me that I have a value for my p hat. Right there, this statement says that p hat is equal to 0.4. That's excellent because I also know then what my q hat is. It's just the complement of that is 0.6. So this problem becomes straightforward. All I got to do is plug in what I need. I know that my n is equal to my zeta value, which was 2.58 quantity squared times p hat, which is going to be 0.4, times 0.6 for q hat, and I'm going to use the margin of error on the denominator. In this case, my margin of error is no more than 5%. That's the last statement there, so it's going to be 0.05 quantity squared. I'm going to do this numerator and denominator step by step on my calculator because I want to make sure that I get everything in there correctly. So when I type this into the calculator, I should get the numerator, I get a value of 1.598 when I round, and the denominator, I get a value of 0.0025. Typing that into the calculator the second time, I end up getting a value of 639.01, and even though that 0.01 is very small, it's saying that I need a little bit more than 639 people, so I'd have to round up to 640. 11b is very similar. The only difference is now I'm assuming that I know nothing about the sample population. When you know nothing about the sample population, you've got to make it the worst case scenario for p hat and q hat. So in this case, my p hat is going to be the same as my q hat, and the only way that occurs is if that's going to be equal to 0.5. I'm going to use the same confidence interval, so I'm going to use the exact same zeta value. So my equation to find n is going to be zeta alpha over 2 quantity squared times p hat times q hat all over the margin of error squared. In this situation, so there's all my values typed in. I'm going to go ahead and kind of shortcut over this annotation that I did here about p hat and q hat. I'm going to type this in separately on my calculator step by step so I make sure I get the values correct. And I should end up getting the numerator to be equal to 1.664, denominator equal to 0.0025. And when I calculate that into the calculator the final time, I should be getting that the number of people needed to estimate the population proportion is going to be 665.64. So 666 students needed to estimate that true population parameter, and hopefully you've got that.